Hi, my name is Ayman Fahd, and I'm here to present my topic flood estimation studies using the hydrological modeling system HARMAS for Batu Bahat River, Malaysia. Introduction. Throughout the last 30 years, flood have become a serious social risk in Malaysia. Changing in flood patterns are due to climate change, land use, the growth of urban and the human. The district of Batu Bahat has been faced flood disasters several times during the last 30 decades. The study was focused at the Batu Bahat city experiencing different types of flood that often occurred through the year. The main goal of this research was to use DID data to develop the HMS hydraulical model. The hydraulical modeling can be used to assess the rapid increase in flood events in Malaysia, as well as protected the water store problems due to climate change. The hydraulic flood simulation has been carried out on the Batu Bahat River, Johor, Malaysia. The historical rainfall data was used to query the hydraulical model to simulate the flood events entering the catchment on the river. The study summarized the part of using of her mass runoff studies. Proposed methodology, area of study. The district of Batu Bahat has a population over the half million people, and the total area is 1,872 square kilometers. The town developed over the eastern bank of Batu Bahat River, for which it gets the name. The urbanization rate is related to the population growth, and the projected that the urbanization will be 95% in 2015. The long term means the monthly rainfall at Batu Bahat station is 2,757 mm, and the mean potential evaporation rate is 1,324 mm. The length of the river is 12 kilometers long. The area of study, here the location of the study area is in Batu Pahat Basin and upstream river. Map of Batu Pahat River area. So the data collection. Data were collected from the ID Malaysia, such as the rainfall data and the water level data. The collected data will be from 2010 to 2020, where will be used in this study. Two different stations has been pointed in this study to analyze and estimate the hydrological behavior for Batu Bahat River. Analyze the hydraulical data. Monthly runoff estimating the models utility monthly observed discharge and monthly skills forecast models using the annual value are two types of statistical modeling of the hydraulical dataset. Trend analyzed by Mankandal test. So, so to estimate and determine the behavior of the river for Batu Bahat. So we studied the trend for the river. So either is it increasing or decreasing for the last 10 years. It's from 2010 to 2020. The intensity duration frequency will be studied for the area and we'll be creating a curve for one rainfall station located in Sungai Batu Bahat with the different storm duration. 13 and 16, 120, 12 hours, 24 hours, and 72 hours. And the return period will be 11 years. Rainfall intensity. So to find the A for the rainfall intensity, we have to find the T, the average of interval, D, the storm duration in hour, and the other factors or quantities based on the location and the rankings. Rational method for runoff. Q is equal to the maximum rate of runoff. C is equal to runoff coefficient that based on the runoff value of the area and the average rate of rainfall depth over the given duration of the area. I is equal to the average intensity. A will be equal to the area. Heck HMS. In this study, we use the semi-distribution hydraulical model for Heck mass. The Heck mass model is capable for simulating the rainfall and runoff relation for the district watershed in space and time. The software model has been used successfully in different parts of the world river basin for the catchment modeling. The initial and constant loss model. The initial and constant rate loss model focused on the FC, the maximum potential rate of the precipitation loss, being constant during the event. Result and discussion. The rainfall trend analysis has been done. The rainfall trend analysis for last 11 years for one station in over the Batu Bahat with the maximum annual rainfall occurrence in the year of uh, 2014 with the total rainfall of 3,111 mm. The main candle test was done for the monthly time series as described in the next section. Using Excel stat program for non-potential candle test was used to determine the trend of rainfall for 11 years from January to December for each year individually. And here in this figure show that the p-value this station was less than 0.001, but the trend line shows that it's at negatively and decreasing from 2010 to 2022, and the candle tau value was minus 0.233 for Batu Bahar station. So that means it's a significantly negative trend of the rainfall in the station. Water level trend analysis. The water level station in Batubat had been annually maximum water level was in 2012. So over the course of the 11 years period, the average rainfall is 10.95 mm. So based on the study, the candle tau value of Batubas station was minus 0.437. So that means it's decreasing. So that means the trend is decreasing downwards. Then the intensity, duration, frequency IDF. The IDF curve is plotted with the rainfall duration as the horizontal axis and the rainfall intensity as the vertical axis. As the figure shows, the result from analysis of the rainfall data using the extreme value distribution or Gable method for Patobahat using the rainfall situation data for the area. The Differential method for runoff. Based on the area of study, the catchment area was 2.04 km and the length is 5.78 km. The average catchment slope is 0.001228 m over m, while the time of concentration Tc is 20.502166 minute, and the average rainfall intensity is 2290.854 mm per hour. So the Q it's equal to 960.631. So in this study, the HECMA software will I mean separated to the 13 sub-basin and 11 junction for the area, so to cover all the study area. In conclusion, the trend line shows that it's a negative and decreasing from 2010 2020 for both rainfall and water level data for our study area. And this research also carrying out in order to do flood estimating and forecasting in the future. The finding of the study might be useful for the government in terms of water management and forecasting the future climate disasters. As a result of this study providing a significant and new incentive and restrictive for the policy markets and planner in order to assist them to take the prevent action in the face of climate change and the flood evil. The flood can cause a primer damage and time stops and unstable adjustment can be surely help to reduce the damage. In order to improve the performance of the trustworthy flow simulation, the HackMass is linked with the geographic information and the remote sensing system. The HackMass model is excellent in simulating the rainfall runoff analysis. The data enable basin management, the hydrological agency estimating and access the management authorized when the planning catchment and the future studies for the river basin. In this study, we propose more investigation to use and provide more executive modeling information and to use calibrated parameter value in the different catchment area for modeling the runoff. And thank you so much for your listening and your time.